Okay, this is a demonstration of the new controller board that I've been working on now. It's fully functional, apart from the FET modules which I haven't added yet. I'll power it up. Okay, I'll go through each function one at a time. On the left hand side of the screen you can see a cursor, and using the rotary thumb switch, which you can see there, I can move the cursor down. The top row is frequency, we've got pulse width, next one down, phase, sweep, which can be switched between sweep frequency or sweep phase. Next one down is to set the maximum sweep range. I'll go through all these individually, and the bottom one is to store the current settings before we power off. So with the frequency, you press the switch on the thumb encoder once, just short press, and it moves the cursor in one, and that allows us to start adjusting each row, in this case the frequency, and by turning it we can turn up. We're on the minimum increment at the moment, and I'll go through that in a minute. But turning it one way, basically we go up in frequency, turning it the other, we go down in frequency. If you press and hold the thumb encoder for more than 1.5 seconds, then we go to an increment, which again, turning the encoder, we can adjust that. And with frequency, there's either a choice of 1, 10 or 100. These aren't actually relevant to the frequency, they're actually relevant to the binary pattern. It was too complicated for me to do increments of, say, 1 kilohertz or 1 megahertz, because the actual mathematical formula to calculate the frequency is non-linear, so it would have been quite hard work to do that. But anyway, this works fine. So to get out of increment, you press and hold the thumb encoder just briefly, and you go back to frequency. Now we're incrementing in hundreds now, so you can see it's a lot coarser response, and I can keep going right up. Actually, I can go to 1,000 increments. Oh no, it's 100 on the frequency. But anyway, you can see we're going up. So you can see in the scope in the background, we're going up in frequency now. Top end is 21 megahertz, and it takes a bit of fiddling around. We can go back down to 1 resolution to finish it off. It's probably a bit fiddly trying to find an exact frequency, but that's the way it is. I've done as best I can do with it, and I think we're doing a pretty good job. Actually, it's 22 megahertz top end on the frequency. So there we go. Just move it back down. So bottom end is 1.039 kilohertz, and top end is 22 megahertz, just under 22 megahertz. Let's do the increment again. Okay, so I'll press this quickly, and we go down to the pulse width, and you'll see the top end of the pulse width is actually 63.25 nanoseconds, 63.75 nanoseconds. Going down, if you're watching the scope in the background, you see it going down. We're on 50 nanoseconds, so I'll move that up. It's 25, 10 nanoseconds resolution on the scope, and I'm going down. It's quite jittery on the scope. I think that's actually my scope. Hope it is anyway. It's never been very good with short narrow pulses. You see them rounding off at about 14 nanoseconds. I keep going down and they start reducing in amplitude until they sort of disappear. I mean, theoretically I should have 3 nanoseconds there, but I think that's probably my scope. The bandwidth is only 25 megahertz. So I'll whip the pulse width back up just for testing. And knock it up to the top with the tiny base in. Okay, so we come out of pulse width, we go down to phase, and phases again, you've got you can manually adjust it. It's going up in 250 picosecond steps, but again, if you press and hold, you get an increment of 0.25, 1, 10 or 100, and those are in in this case 0.25, though it's measured in nanoseconds. So if we wanted to say 1 nanosecond steps, then I can come out of there and I can just increment the phase. You see the scope, the phase moving on the scope. I'll move it, increment up again, go up to the maximum of 100 nanoseconds. And you will see there the scope's on 500 nanoseconds per division, and we are round about, yeah, it's about right anyway, according to my scope, although my scope's probably not as accurate as this actually is. So there you go. Now I'll put the increment back to 1 for the moment. If we come out of there and we go down to sweep, now with sweep we've got a plus 15 to minus 15 range, or minus 15 to plus 15 range, and that is actually the speed for the sweep. Now you see we're set at sweep frequency. If I press and hold the encoder switch, it switches to sweep phase, so we can alternate between sweep frequency and sweep phase. Plus 1 is the slowest speed, and you can see now that phase is actually incrementing, and it will increment at the increment setting, so we could make it a sweep a lot faster by going into phase and altering the increment setting. I can go up to 15. 15 is the maximum speed, and you see it going up now. You see the phase on the scope altering. Actually I'm triggering on the second channel, so anyway. Now if I go back down to 0, you see that the sweep's finished. 1, it's very slow. I can go negative as well, where it starts going down. Minus 1 is very slow going down, and we can go down to minus 15, which is the fastest. When it reaches the bottom or the top, it will automatically roll over. Now I'll stop the sweep for a second. It will automatically roll over, and we can actually set that. Now because we're on sweep phase, the next one down is set sweep max. Now the phase is set to 358.25. If I press and hold for 1.5 seconds on the set max, it sets the actual maximum point that the phase can go to before it resets back to 0. So if we come back out of that now, I've set the sweep max, and we go back to sweep phase. If I go back in there and click up, it will roll over as soon as it hits that maximum. You've seen it now hit that maximum and roll back over. White sweeping, I'll come out, go back up to phase, and I'll go in and alter the increment. We can do all this white sweeping. I mean, it just, it does everything there. If I alter the increment to 100 and come out, you see it now going up in hundreds, and because we had the maximum point of just over 300, of course it's hitting 300 and going back down to 0. Again, we can use any increment setting we want that's available really for different levels of scanning. Obviously the higher resolution scans, sweeps, can take quite some time because there's quite a range there. I'll go in, I can sweep, I can speed that up. You see it going round and round, and if I now press and hold on the sweep phase, we can switch back to sweep frequency. You see the frequency going up, you see the scope going in, and it'll keep going round and round. And again, if I stop that, there, come out of sweep frequency, go down, set sweep max. This time, because we're on frequency, setting the sweep max sets the maximum for frequency. Come back out of there, go back up, go back into sweep frequency, and as you can see it's rolling over between the maximum point we set. If we go down, it will hit 0 and then reset to the maximum frequency that we set. Okay, now we can come out of there. Now the last setting at the bottom is, again, you press and hold your thumb encoder, and basically it stores all of the settings that we have at the moment into EEPROM, so that if we power off and power back on, it remembers everything that we've set, absolutely everything. All the frequency settings where we were sweeping frequency, it's remembered all the increment settings, everything's stored, ready for power up next time. So basically it powers up exactly where we left it the previous time.